Hi, this is Daniel Ziegler, and this is my 8 puzzle program for CSC 480. I'm going to try and make this very quick so that I don't go over the time limit. So here's a quick overview of my program running. You can view the starting configurations, the easy, medium, and hard, but for now I'm just going to solve a puzzle. To make things easy, I'm going to just choose the easy configuration and go with a breadth first search, for example. You can also choose a maximum search depth. I'm not going to do that. There is no maximum here. And here we go with the result. You can see that it has a solution. It shows you each of the individual states along with the operator that was used to get there, none to begin with, the cost of that operator, and the total cost so far. And so as you go down the whole thing, at the very end you'll get the final cost of the whole solution, the time, solution length, number of nodes popped, and peak queue length. So that's about it for the actual execution. Let me take you into the implementation real quick. Each of the states was represented by a node class. The node class has a linked as actually an array of integers, which is just an array of 9 of them to represent the whole state. You can see they're set right here. It also has things for a parent, children nodes, action that was taken, path, cost, depth, and heuristic just indicates the result of the evaluation function that was used if the algorithm uses that. Now the actual search algorithm is done in this agent class. As you can see, it takes a number of things: initial state, goal state, etc. Mostly it just implements the whole general search algorithm. So as you can see, while it's not empty, it pops one off the end of the linked list. Actually, rather, it pops one off the front. Checks whether it's equal to the goal, and if it is, then we just push it onto a stack, move the stack onto a queue, and return that. So instead of just returning the node itself, it returns the full stack of it, and that basically lets you just print out the whole thing in order. Adding to this, we use a queuing function. The queuing function is not actually abstract because some of these algorithms don't actually use it. Instead, they might need to use the heuristic function, but some don't need that. So the queuing function, for example, in breadth first agent, you can see it just takes all the nodes in the list of expanded nodes and adds it to the end of the queue. So it's more like a queue, whereas the depth first agent just pushes it to the front of the queue instead of the end. Best first agent, meanwhile, does something a bit different. It does implement the heuristic. It does override the heuristic function here to assign a new evaluation value to whatever node is passed in. And then for the actual search, it uses this priority search algorithm, which is almost the same as the regular search algorithm, except instead of using a linked list, it uses a priority queue. That way, it'll get sorted in order from least to greatest. What order it's sorted in depends on the heuristic function. So, for instance, best first, uniform cost will just take whatever the path cost is and use that. This is why the node class also implements the comparable whatever it is. I can't talk right now. This is late at night. Anyway, for the rest of this, checking for duplicates, we do have continuous state checking. This is done by using a queue called history, which just keeps track of all of the. It should be in here somewhere. I know for a fact it's here. Here it is. It just keeps track of all the nodes that are in there already. So whenever you're doing this, whenever you're doing the expand function, you call the successor function. It checks all of the possible actions, the operators, and it checks whether it's already visited that node or not. It won't add it if it hasn't. As for adding things to that, I also have a separate function for that checks whether a state is already in that history queue, so we don't have any duplicates there either. That should be about it for the assignment. I hope it meets the requirements, and I will see you soon. Thank you.